All right, this is Physics Chapter 15. We're going to finish the chapter up with this lecture. In your notes, we are on page 4, and we're starting at the section Fuses and Circuit Breakers. So in class, I pass around some examples of fuses and circuit breakers, and I will try to find a video that explains the difference between the two and put it in the description box. But a fuse is just a thin conductor that breaks when too much current passes through. So fuse and circuit breakers are safety devices. They cut the current off to a circuit. They shut down a circuit when that circuit is overloaded. So that's to keep a fire from happening. Okay, so the fuse has a thin conductor in it. They're rated at a certain number of amps. A common household fuse would be 15 amps. So if the current gets above 15 amps, that thin conductor will break and it's an open circuit, so current won't flow anymore. With a circuit breaker, the difference between a circuit breaker and a fuse is that a circuit breaker you can reuse. So it trips. Two pieces of metal are taken apart, and so the circuit no longer, current won't flow in the circuit anymore. So if you go look in your panel box, you'll see mostly 15 amp circuits. That's for, your standard lighting and receptacles. You'll see some 20 amp circuits maybe for the kitchen, and for your air conditioning unit you might see a 30 amp circuit breaker for that. All right, so let's look at 15.7 on page 511. All right, so for that one, you can see, just looking at this, we've got a simple circuit with a 120 volt source, 2 resistors, and we have a fuse right here. It's just symbolized with a rectangle there in the circuit. And it's asking what fuse we need to use. So what we need to do for this circuit is figure out the current, because a fuse is a current device. And we want to pick the fuse that's just above the current in this particular circuit. All right, so we know that V is equal to IR. So I is going to be V over R. That's 120 volts. Now the resistance is, those resistors are in series, so it's going to be 8 plus 5, or 13 ohms. So the current in this circuit is 9.23 amps. So what fuse would you use? Well, you wouldn't want to use a 5 amp fuse because it would trip all the time. The circuit would trip. The fuse would be destroyed. You want to go just above that. So for this circuit, you'll use the 10 amp fuse. All right, 15.8. So in 15.8, it asks us to calculate the power. And I'll just draw this real quick. All right, so we've got 3 resistors in parallel, and our voltage source is 120 volts. We've got 15 ohms, 25 ohms, and 12 ohms for each of the resistors. So hopefully you can tell that those are wired in parallel. So our effective resistance will be 12 to the minus 1 plus 25 to the minus 1 plus 15 to the minus 1, and you have to raise all that to the minus 1 power. Okay, so when you do that, you'll get an answer of 5.26 ohms. So now we can get the power of the circuit. I'm going to use V squared over R. So that's 120 volts squared over 5.26 ohms. And you'd get 2,738 watts. Here we go. We are cooking in this chapter. All right, so that 15.8 is on page 512. All right, if you need to pause the video, go ahead, and I will erase this. Okay, we're on page 5 in your notes. We'll look at 15.9. So 15.9, which is on page 514. It says, which fuse would you use? So I'll draw that out. All right, our fuse is right here. 9-volt battery, resistor of 1 ohm, 3 ohms, and 2 ohms. So what kind of fuse would you use? A 1, a 3, or a 5 amp? Okay, so we're gonna have to do a little bit of work here. This circuit has both resistors in parallel and also in series. These two, the 3 and the 2 ohm resistors, are in parallel. So the effective resistance for that branch, okay, that's a branch, is 3 to the minus 1 plus 2 to the minus 1 to the minus 1. All right, so that is 1.2 ohms. So we could redraw that circuit like this. So we've got 1.2 ohms. So I just took the effective resistance and replaced those two resistors with a single resistor and 1 ohm. Now, those two resistors are in series, so we add them. 1 plus 1.2, 2.2 ohms. All right, and we want to know what fuse goes there, so what you have to do is solve for current. If V is equal to IR, then I is equal to V over R. That's 9 volts over 2.2 ohms. All right, your calculator will tell you that is 4.09 amps. Okay, so which fuse would you choose? The 1, the 3, or the 5 amp? All right, hopefully you said the 5 amp fuse. If you picked 1 or 3, the circuit's going to trip all the time. But 5 amp isn't so much greater than 4 amp that it's going to cause the wiring the insulation on the wiring to melt and to burn up. All right, so we've only got one more to do, and this chapter's lecture will be done. Okay, that 2018 I just erased has nothing to do with this video, by the way. So that is for a previous calculus video I did. So sorry I forgot to erase that. These videos are being done in the COVID-19 crisis of 2020, March of 2020. All right, 15.10. Okay, so I'll draw that one out and see if I can fit everything on the board. So we've got a circuit that has 3 branches. You can draw along with me if you're filling out your notes. If you're just watching, then you can just watch. Okay. So what we've got is we've got 3 branches that are in series, but in each branch you have parallel resistors. So 22, I'm not going to put the omega for the ohms, 29, let's try to save space here, 13, 15, 39, and 31. This is 120 volts. We want to know the power of that circuit. So in blue, I'm going to do the effective resistance of each branch. All right, so this top one would be 13 to the minus 1 plus 15 to the minus 1, all to the minus 1. All right, and that is 6.96. For this branch, I've got 39 to the minus 1 plus 31 to the minus 1 to the minus 1. And that is 17.3 ohms. And in this branch, I've got 22 to the minus 1 plus 29 to the minus 1, all to the minus 1. And that is 12.5 ohms. So I could redraw that circuit with just 3 resistors in it. All right, so still 120 volts. And I got 17.3 ohms. 6.96 ohms and 12.5. So for that circuit, the total resistance, those are all in series, so we just add them up. 12.5 plus 6.96 plus 17.3. And that is 36.76. Now we can figure out the power. So power is equal to V squared over R. So 120 volts squared over 36.76 ohms. And that is 391.7 watts. Okay, so we're done with the book part of the chapter. There's one, go ahead and pause the video if you need to keep writing. Okay, I do want to talk about, because this, you will be responsible on your tests for knowing how you calculate capacitance in a circuit. So if you look at the very bottom of your notes, you won't have any that you have to do the math, but I do want you to know for capacitors in series, it's basically the opposite. How you calculate effective capacitance is the opposite of how you calculate effective resistance. So 1 over the effective capacitance is equal to 1 over C1 plus 1 over C2 plus 1 over C3, and on to however many capacitors in series that you have. So kind of like resistors in parallel. And then capacitors in parallel, you calculate that effective capacitance like you would resistors in series. So it's just C1 plus C2 plus C3. All right, just need you to know that, be able to answer a true, false, or a multiple choice on the test for that. We're not going to put any of those in our circuits. If you ever take an electrical engineering class, you will have to deal with that. All right, that ends our chapter 15 lectures, and see you next time.